Welcome to Brainbox. In present session, we are going to check with the reaction of metals with non-metals. See here, once we understand this, metals reactivity or the metals way of reacting is completely opposite to that of non-metals, right? And the reason is that metals have a most tendency to lose the electrons, but the non-metals have the highest tendency to gain the electrons. So that the metals, after losing electrons, metals have tendency to lose electrons. Okay, now after losing electrons, they form cations. Okay, so let's see how they are going to form cations. For that, I'll explain you about the formation of NaCl. Formation of NaCl. So NaCl is actually an ionic compound which is formed by a combination of a metal sodium with a non-metal chlorine. Right. Now in this, first thing we will check how Na plus ion is formed. So if NaCl has to be formed, what we need? We need one cation and one anion. Right. So first we will see formation of cation. So what is a cation? Na plus. See, you know well about this sodium. Sodium, what is the atomic number? Atomic number of sodium is 11, right? And how does it exist? We can write it as 1s2, 2s2, 2p, 6 and 3s1, right? In the sense, in the first internal cell, means let us say how atom is existing, means let's say this is your nucleus and around the nucleus you have shells. So this is your first shell where you have 2 electrons. So what are the number of electrons present in first shell? 2 electrons. And in the second shell, how many electrons are present? 2 in the S and 6 in the P. In the sense, total 8 electrons are present. How many? 8 electrons, right? And moreover, the third shell if we have, so this is our third shell, what we can say. And in the third shell, means in the outermost shell, there is only 1 electron, right? And see, if at all by chance, if this sodium loses 1 electron, then it is going to get the 8 electrons in the outermost shell. Means what happens if we removed this 1 electron? Then the inner shell or second shell is going to become the outermost shell. So that what is the configuration? So let's say this is the configuration of sodium. Then what is the configuration of Na plus ion? Na plus ion configuration is only 1s2, 2s2, 2p, 6 means 8 electrons in the outermost shell. So to get or to attain that 8 electrons in the outermost cell, sodium readily loses electrons so that the sodium forms cation. Okay, and similarly, if we have seen that non-metals, so non-metals have tendency to gain electrons. Okay, and after gaining, they form anions. Okay, so let's see how anion will be formed. So formation of anion. So for the formation of anion, first we will take the nucleus, and around the nucleus, let us take this as a first shell, and then second shell, and then third shell. Okay, and moreover, before that, see, I'm going to discuss about the chlorine, right? So the configuration of chlorine, actually it has 17 electrons, means it will be like this: 1s2, 2s2, 2p6, 3s2, 3p5. See that whole 17 electrons. 1s2, 2s2, 2 plus 2, 4 plus 6, 10 plus 2 plus 5. Totally 17 electrons are present. Right? Let's try to accommodate these electrons in the shells. See in the first shell, 1. How many electrons? Only, right? Second shell, 2s2, 2p6. Totally how many electrons? 8 electrons here. So the 8 electrons we have arranged like this, right? And then the outermost shell, 2 plus 5 means there are only 7 electrons, right? So 1, 2, 3, 4, 5, 6, and we have only 7 and need one more. Okay, because any atom or ion will be stable if it has 8 electrons in the outermost shell. Now see, sodium has only 1 electron in the outermost shell, so it readily loses that 1 electron, so that in the inner shell, in the sense second shell, it at least will get the 8 electrons. In the sense, after losing 1 electron, second shell becomes the outermost shell for the sodium, so it gets the 8 electrons. So it readily loses electrons. Now anions, how anions will be formed? The atoms which has more tendency to gain electrons. So this is the tendency of non-metals. Non-metals always readily gain electrons. See here, I have shown you about the electronic configuration of chlorine, where in the outermost, here for chlorine the outermost shell is third shell. Right, in the third shell there are only 7 electrons, and to complete its octet it needs one more electron. Right, so what happens? Chlorine readily gains electron, and after gaining electron it forms anion. Right, and here now sodium cation reacts with the chlorine anion to form NaCl, and this is called as ionic compound. Okay, what do we call this compound? This compound is called as ionic compound. So from this, what do you understand? What is an ionic compound? Ionic compound is one which is formed by the combination of a metal and non-metal. Because here one metal is there means it always will have the tendency to lose electron, and at the same time a non-metal has a tendency to gain electron, so that the atom having tendency to lose electron forms cation, and the atom having tendency to gain electron will form anion, and a compound which is formed by the combination of a cation and anion is always called as ionic compound. So in ionic compound what will be present? Ions will be present. And what are the ions present? Cation and anion. Right? So what is ionic compound as a whole? Compound formed by cation and anion. This is called as ionic compound. Right? Now let us see the properties of ionic compounds. Properties of ionic compounds. Okay, so what are the properties of ionic compounds? See, first thing, they are formed by the cations and anions, means a combination of ions, right? So because of this, they are having a bond which is called as ionic bond, right? So they possess ionic bond. So because of presence of ionic bond, they are hard solids and possess high melting and boiling point. So possess ionic bond and they are hard solids with high melting point and boiling point, in the sense MP and BP. Okay, and next, see, these compounds have ions, right? So as they are having ions, basically they are soluble in polar solvents. So polar solvents like water. Water is an example of polar solvent and they are completely soluble in polar solvents like water, right? And moreover, they conduct electricity. They conduct electricity. See, remember this point, they are basically solids, but they are not going to conduct electricity in solid state, either in dissolved state. Means if at all we have dissolved this compound in some other solvent, see, we just have discussed that they are soluble in polar solvents. After dissolving the given ionic compound into the polar solvent, they can form the compounds, means they can form a solution, and that solution is electrically conducting. So they can conduct electricity in dissolved state or molten state. Okay, see, you can understand very clearly why they will conduct electricity only in dissolved or molten state, why not in the solid state. See, if you understand this, see, a sodium cation is forming bond with the chlorine anion, right? In this, when they form bond, see, the bonding will be clearly explained like this. One Na plus ion is completely surrounded by all Cl minus ions like. Okay, now this Cl minus ion is again in turn surrounded by all Na plus ion. In the sense, no atom in the solid state is free, right? Each and every atom is completely packed by the opposite ions. In the sense, a cation is completely surrounded by anions and anion is also completely surrounded by cations. So because of this reason, naturally in solid state, ions cannot move from one place to another place, and they need to conduct electricity, means ions must move. And where the ions can move? Ions can move only in either dissolved state or in the molten state. So that is what ionic compounds can conduct electricity only in the dissolved state or molten state, right? So these are the properties overall of the ionic compounds. All ionic compounds possess ionic bond, which is strong electrostatic force of attraction, right? So because of the strong electrostatic force of attraction, they are basically hard solids, right? And they even possess high melting points and boiling points. See, NaCl, you would have seen it is a hard solid, right? And similarly, they are soluble in polar solvents like water. See, sodium chloride readily dissolves in water. Okay, and similarly, they conduct electricity in the dissolved state, means they do not conduct electricity in the solid state. They conduct electricity only in the dissolved state or molten state, right? Have a look now.